Fine. Now let's see what are the various types of operating systems we have. Okay. One thing is nothing but batch operating system. Batch operating system is actually not used today. It is being used long back. Okay. Batch operating system means in the degree of multi-programming is always 1. Okay, that is in the batch operating system we will be always having the degree of multi-programming as 1, which means at max there can be only one process which can be present inside the RAM. What do I mean by that? See, we will be actually placing a process from hard disk into RAM, right? And then CPU will execute it. Now, what we will be usually doing is, whatever we have seen so far, what we will be doing is, we will be having more than one processes inside the RAM, right? I have not explained it actually till now. Let me explain it now. Usually what we will be having is, we will be having more than one processes. For example, P1, P2 and P3. By having this, I'm going to have a lot of advantages. Why? For example, let us assume P1 is being executed by CPU. Okay, P1 is being executed by CPU. Now, P2, let us assume P2 needs IO. Okay, now P2 can undergo IO from some, which means it can read data from some of IO devices, some IO devices. Okay, now and P3, whenever P1 is done, P3 can continue with CPU, which means what I'm actually doing is I'm actually making both CPU as well as IO devices to work in parallel, right? Whereas let us assume if I restrict my computer to say I can have at max only one process which can be present inside the RAM, right? Then what I will be doing? I will be placing one process inside the RAM. Only after the completion of this process, I will be fetching the next process from the hard disk. The disadvantage with this is, let us assume P1 needs IO. Now whenever P1 is doing IO, our CPU will be idle, right? See, execution and IO cannot be done at the same time for a particular process. It can be done for two processes, which means when a process is being executed by CPU, we can actually perform IO for another process. That can be done, okay? But here, since we have only one process in the RAM, when only after the completion of this process we will be able to take the next process from the hard disk. Okay, now because of this we are going to have less efficiency, CPU efficiency. Okay, CPU efficiency is nothing but useful time of CPU divided by total time of CPU. Which means out of the total time you have got, how much time are you really using the CPU, right? In case if the CPU efficiency is 100%, which means we are not actually having the CPU idle. We are using the CPU completely, okay? And in that case, the computer will be very fast. Why? See, we need to make use of the resources as much as possible, right? For example, let us assume if 5 people are working in a project, if all 5 of them work together at the same time, if all 5 of them are work together without taking any rest, then the project will be completed very fast, right? Now, in case if 1 or 2 of them take some rest or be idle, which means they are actually not working to their full potential, in that case it will take more time for the project to get completed, right? The same is what is happening here. We need to execute lot of processes, and if we make use of our resources means CPU, IO device or anything, if we make use of it completely, then actually our computer will become faster. Why? Because more processes are being executed at the same time, which means if one of the processes is being executed, then the other process can undergo IO. So our computer's fastness will improve, right? Now that is not possible in our batch operating systems, because at max we will be taking only one process, and only after the completion of this process we will be taking the next process from the hard disk. Okay, that is the disadvantage coming to batch operating systems. Now we have one more operating system, multi-programming operating systems, which is very popular. Multi-programming operating systems is nothing but we can have more than one process in the RAM. So far whatever we have seen, which means we said that we can have more than one process in the RAM, right? If P1 is being executed by the CPU, then one of the other process can undergo IO. Okay, that is what we mean by that is what we mean by multi-programming operating systems. Why? Because we are having more than one process inside the RAM. This is going to improve. One thing is CPU efficiency, which means useful time by total time is definitely going to improve, which means if one of the processes is undergoing IO, I can actually use some other process, I can actually execute some other process, which means I'm not allowing the CPU to remain idle, right? So CPU efficiency is going to improve because of multi-programming operating systems, okay? And also the computer's fastness will improve. As the CPU efficiency increases, the computer's fastness will also improve, which is very obvious, right? Now we have one more operating system which is nothing but multi-processing operating system. See, so far whatever we have seen, either batch OS or multi-programming OS, the number of CPUs is only one. Okay, in our computer, which we have seen for batch OS and multi-programming OS, there can be only one CPU. Okay, but in multi-processing OS, we can have more than one CPU. Okay, see, so far whatever we have seen, we had only one CPU and we kept on taking the processes and then it is being executed. But in multi-processing operating systems, if more than one CPU is present, what can happen is, if while one process is being executed by this CPU, some other process will also be executed by this another CPU, right? Actually what we are doing here is parallel processing. Parallel processing means we are executing more than one process at the same time, right? But in multi-programming operating systems, we were not doing parallel processing, right? We were actually doing concurrent processing. See, there is a difference between parallel processing and concurrent processing. There is a difference between parallel processing and concurrent processing. If let us assume in case if we have only one CPU and if we keep on changing the processes and if we keep on executing, then we say that as concurrent processing. Let us assume there is a mother who is actually feeding her two children using both her hands with the spoon. Okay, she has taken two spoons and then she is feeding both her children. Okay, which means she is giving food to both her children. Now this is nothing but parallel processing. What is happening is she is giving the food to both her children at the same time using both her hands, right? This is what we mean by parallel processing. Whereas in case if she uses only one hand and if she gives one spoon to her one of her children and if she gives some another spoon to some other children and if she keep on doing it interchangeably, then we say that as concurrent processing. It's a very funny example, right? So but still it actually helps to understand. So that is the difference between parallel processing and concurrent processing. The disadvantage with parallel processing is, see, definitely parallel processing will be faster than concurrent processing, that is for sure, right? But actually the disadvantage with that is, in parallel processing the system cost will increase, right? The system cost will increase because we are having more than one CPU. The cost of processor is very high today, right? In case if we have two processors, the system's cost will become very high. So that is the disadvantage we have with multi-processing operating system, right? See, whatever we are using today in our computers is multi-processing operating systems. Why? See, you should have heard that octa-core processor, quad-core processor, right? What is meant by quad-core processor? We have four processors which are placed in our computer. That's what we mean by quad-core processor. Whereas octa-core processor means we have 8 processors which are placed in our computer. Okay, so that is all this we all computers we are using today is nothing but actually working on the basis of multi-processing OS, right? Fine. So these are the various types of operating systems we have. Okay, so what are the things we saw? we saw what is meant by degree of multiprogramming, which is nothing but the maximum number of processes which can be present in the RAM. Then we saw something called as, then we saw what are the various, what is meant by CPU efficiency. CPU efficiency is nothing but useful time of CPU divided by total time of CPU, which means what is the total fraction of time which we are utilizing the CPU out of the total time. That's what CPU efficiency means, right? As the CPU efficiency increases, which means as much as you are using the CPU, utilizing the CPU's time, the more faster the computer will be. Okay, that is what CPU efficiency actually. That's why CPU's efficiency is very important. Fine. Then we saw something. What are the various types of operating systems? Batch OS is nothing but we will be having only one processor, and we'll be having at most one process inside the RAM. That's what we mean by batch OS. And batch OS is very slow because the CPU efficiency is very less. Then we saw multi-programming operating systems. In multi-programming operating systems, we can have more than one process in the RAM, and so multi-programming operating systems will be much faster than batch OS because the CPU efficiency is much better. Whereas multi-processing operating systems, we can have more than one processor, and also more than one process can be present inside the RAM. See, in multi-programming OS, we can have at max one processor, but we can have more than one process inside the RAM. In multi-processing operating system, we can have more than one processor as well as we can have more than one program in the RAM. Now, multi-processing operating system is definitely faster than multi-programming OS, but multi-processing operating system suffers from a disadvantage that the system cost will increase.